by arranging two congruent triangles. Am I recording now? I am. Okay, is that the area formula for a triangle comes out of this idea that it is half of a what? Parallelogram. We already showed yesterday that the area of a parallelogram is base times height, so the area of any triangle is what?
Base times height divided by 2.
Very good. Base times height divided by 2. So the area of a triangle is equal to base times height divided by 2. You know that, don't you? And the height can be measured this way. The height can be measured this way. And we'll do some example. The height can be measured like this way. That's the same height, right? Or you can have a height going this way. As long as that height is perpendicular to the other side, and that is the height of the triangle. Okay? Remember when we constructed altitudes? That's how we did it. Okay? So there's that one. That's pretty easy. Okay? Now we'll get into trapezoids, which are more fun. So I'm going to go down here to these two different. So it says formula, the area of a triangle there. You know that. Okay? Does your conjecture depend on the size or shape of the triangle? Yes or no?
Yes.
Say no.
No.
No, that would be the correct answer, okay? It doesn't depend on the size of shape. So here we have, what they did is they put in two congruent trapezoids, okay? And notice if I drag these around, they remain trapezoids. So the way they constructed that is just it has one pair of parallel sides. And you can get this to move over here. And if I took this and dragged it over to here, what shape does that make? A parallelogram, okay? And let's arrange it so it looks better, okay? So if I arrange it, it looks a little bit better. And so now this parallelogram also has an area base times height divided by 2, right? However, in a trapezoid, this whole base, what if this is base 1 here and this is base 2 here, because this is just this base flipped around, how can I find a formula for the area of this trapezoid right here?
Base 1 plus base.
Nice. Okay? Since this is base 1 and this is base 2, usually they put the ones down below, subscript rather than right next to it. So how would I find the area of this parallelogram, this whole thing?
Well, wouldn't it be base 1 plus base 2
Times what?
times the side?
Not times the side, times the what?
Height.
Height, right? But if I just want to find one of these things, okay, like that one or this one, what do I do with that? Divide it by 2. So that, ladies and gentlemen, that is where the formula for the area of a trapezoid comes from. Okay? So you see, isn't that cool? Isn't that cool? Don't worry, we'll do a little investigation with your computer when we do the picture. Area of a trapezoid is base 1 plus base 2 divided by 2 times the height. And you can see that because it's half of a parallelogram if I took two congruent ones and put them together. Isn't that kind of cool? That's kind of cool. So say yes, that's kind of cool. So for example, they might give you an example problem where they say, okay, here is a trapezoid. Let's see if I can draw a trapezoid. 1, 2, 3. Come on, please work this time. Oh, pretty good, huh? Okay. So here's a trapezoid. Can you? How about you write down some notes? That'd be a good idea, right? Okay. So here's a trapezoid, and say that you're given that this is 10 and this is 8, and then they drop down a height down here like this, and they tell you that this over here is 6. What's the area? How would I do that? You add those together, so you have base 1 plus base 2. So I have it 8 plus what? 10. What's the height? 6. And then you take that whole thing and you divide it by 2. So a lot of times you could simplify this by going like that, changing that into a 3. So you get 3 times 18, which is? 54. whatever the units happen to be, okay? Maybe it's square inches or whatever. Squinches. Squinches. Okay, if those are inches, then your units are squinches, right? Okay? You like those?
Put that on the test.
Squinches. Yeah, that's fine. Thank you, Lena. Okay. All right. So
That should be extra credit.
then that should be extra credit. Okay. And sometimes they do ones which are a little more trickier. So I'm going to try to draw another trapezoid right here. I love this tool. Is that going to make a trapezoid? Oh, didn't pick it up that time. Maybe it only goes if I go the other direction. Oh, there we go. Okay, so here's another trapezoid. Let's change colors. And let's say in this trapezoid that what they tell you is that the area is 80. Let's say squinches again. Squinches. Squinches. I guess you would spell it like that. Square inches. Okay. And what they tell you in this is that this is 4, even though it's not to scale, 4 inches. And this over here is 8 inches. And they want you to find base 2 over, whoops, that 2 should be down below. And they want you to find base 2. Could you do that?
Yeah.
Okay, you do have to do a little bit of algebra. Don't just guess and check, and you want to set up an equation. So you know that the area is equal to base 1 plus base 2 times the height divided by 2. So this is the formula for the trapezoid. So you plug in the numbers. If you're told the area is 80, 80 goes over there. Base 1 is what in this case? Hello, 4 plus base 2 divided by 2 times what? 8. So the way I could do this, I could cancel out this 2 with the 8, because this is times the whole thing right here. So I could cancel that out, and I get 4. Then what? I'm trying to solve for B2. So what I now have is 80 equals 4 times 4 plus B2. How do I get rid of that 4? You could distribute, but you don't have to, right? You could just divide it away, right? Because if you distribute, then you have to do another step. So you get 20 equals 4 plus B2, which means that B2 would have to be equal to 16. Okay? And that would be in inches. So, and you could go back and check to see if your answer works, right? The first base was 4. You want to see it is 4 plus 16 divided by 2. What was the height of that? The height was 8 times 8. Does that equal to 80? And 4 plus 16 is 20. Divided by 2 is 10 times 8 does indeed equal 80 squinches, right? So you did that correctly. Okay? Questions on that? Questions on that? Class, let's see if I can get back to those dynamic geometry explorations. So the next thing we're going to do is talk about a kite, okay? And this one is a little bit different because I don't think you really know the area formula for a kite. And all I'm going to do is I'm just going to arrange these pieces, okay? Whoa, is that cool? That wasn't a very good, let's start over. It didn't come out very good that time. Oh, I didn't want to do that over. Let's start over. Arrange pieces. What the heck? Start over. Arrange pieces. Oh, that's what I wanted to do. Okay, so what I did with this kite, okay, is I took this half, right, this piece over here, this piece over here, okay. This was this part of the kite, right? It was kind of over here, and I reflected that piece. I kind of rotated it and stuck this piece down here to make it look like, what shape is that? It's not a,
It's a triangle.
it's a what?
Rectangle.
No, what shape is What shape is this right here? This thing right here. It's a rectangle. In a kite, what do you call this? Whoops, that's the wrong tool. What do you call this thing from here to here in a kite? That's a bad job. What do you call this thing in a kite from here to here? You know what that's called in a kite? That's called the diagonal. Okay? Diagonal. Okay? What's this thing called? What's this thing called right here? How much of the diagonal is this? So right, if I took the whole kite, right, over here, this is 1/2 of the other diagonal, right? See that? So this is really 1/2 of diagonal 2. So we'll call this diagonal 1. We'll call the other thing diagonal 2 times 1/2 of diagonal 2. And that kind of that would be the area of this rectangle. You understand that? Okay? So this is diagonal 1, and this is 1/2. The width of this rectangle is 1/2 diagonal 2. So the formula for the area of a kite comes out of that idea by showing you that it's the area for a kite is just diagonal 1 times diagonal 2 divided by 2. See? And cool. Like that. And
Wait,
so, what's wrong?
Is diagonal 2, is it from that point to that point?
No, it's at, I'll do an example.
Point to it, point
So I'm gonna just show you do a kite. Let's see if I can make one with my tools. Let's see if it will actually draw a kite for me. Oh, I know I can find a kite. Hold on. What's special in a kite is that 2 of the sides next to each other are congruent, and the other 2 sides are congruent as well, but those are not necessarily congruent to each other, or they can't be congruent to each other. So definition of a kite is these 2 sides are congruent and those 2 adjacent sides are congruent. But say in this kite, I'm told that this diagonal from here to here, that's that picture, is 10. And this diagonal going this way, I'll just do it like, I'll just kind of try to do this diagonal going from here to here. Let's say that that is 8, right? This length right here. So then the area of this kite is just diagonal 1 times diagonal 2 for any kite divided by 2, which is 10 times 8 divided by 2, which is 40, okay? Whatever the units happen to be, okay? And that's how you find the area of a kite. Let's see if I have any more examples based on that. I don't think so. I think that's pretty much it. Okay? So for right now, I'm going to give you like half an hour to start, Makana, on your homework, which is going to be page 418. It's on trapezoids, kites, and triangles. 418, 1 through 6, and then 7 through 27 odd. Okay? And then there's going to be a little extra assignment on finding areas of their word problems involving areas, but I'm not going to give you that yet. So you can start on that, and then after that we're going to do start the PICS formula thing. Okay? The end.